everyone. Thank you for joining me again. All right, so in this lecture, you're going to learn about prospect theory, or loss aversion utility. Prospect theory was developed by Dan Kahneman and Amos Tversky. You've been hearing about these guys, right? As a descriptive framework of how we make choices in the face of risk and uncertainty. And their starting point was the role of loss, right? And we've been seeing lots of examples of that. How people respond to the prospect of loss. So here's one of their examples. Suppose you face a choice between A, a sure loss of $7,500, or B, 75% chance you will lose $10,000, and a 25% chance you will lose nothing. Which one would you choose? Now, notice that the expected loss in either choices, right, the outcome is the same. It's $7,500. It's a loss of $7,500. But would you deliberately choose the guaranteed loss or take a chance, right? In fact, most people would opt for the latter. Why? Well, because nobody likes to lose, right? The uncertain outcome holds out the possibility that they may not have to lose, right? And this phenomenon is called loss aversion. And it's not difficult to find real-world examples of loss aversion, right? The idea of loss aversion also includes, for example, the finding that investors are typically very reluctant to lock in a loss, right? So consider an investment bought at $1,000, for example, right? And let's say that it quickly rises to $1,500, right? An investor would be tempted to rush to sell it in order to lock in the profit, right? In contrast, if the investment had dropped to $500, an investor might tend to hold on to it to avoid the pain of locking in the loss, right? The idea of a loss is so painful that people tend to delay recognizing it. Now, here's a real example from an individual investor who happened to be invested in Stedman mutual funds. And according to Lipper, between June 30, 1994 and April 15, 1997, Stedman funds did not do well, right? In fact, at least one of them had their worst 10-year returns over this period. And throughout the 1950s, 60s, and 70s, Melvin Clark, a math instructor living in Florida, had $1,000 invested in Stedman funds. And his last purchase was at the end of 1974. Now, by June 1997, however, his position was down to $434. Had he invested in the average fund, his investment would have grown to $29,000, right? Yet he kept holding on to his Stedman shares. He could not bring himself to sell, right? The idea of realizing the loss just was too painful to recognize, right? And prospect theory explains all that. So prospect theory has two parts. First, investors find the pain of losses to be greater than the joy from gains, right? So preferences described by prospect theory or by loss aversion utility allow investors to have different marginal utilities for gains and losses, right? So that's very different from typically the mean variance preferences that we think of. Second, Kahneman and Tversky went even beyond probabilities, not even subjective probabilities. In their formulation, they used decision weights which did not necessarily obey probability laws, right? They do not, for example, have to sum to 1 like probabilities. What this allows, however, is that they allowed investors to potentially overweigh low probability events like disasters or winning the lottery. Right? Okay, so here is a graph of what a typical loss aversion utility function looks like. Right? So notice that the utility is defined relative to a reference point. Right? Now, this could be 0, or it could be some benchmark return. Right? And gains are defined as positive values on the x-axis, right, on this side, right? And losses are defined as negative values on this side, right? Now, notice that the utility function has a kink, right at the origin. So there is an asymmetry in how investors treat gains versus losses, right? The utility function is concave. Let me change that color, right? It's concave when it comes to gains, right? So investors are risk averse on this side when it comes to gains, right? But the utility function is convex over losses, which captures the fact that people are risk-seeking over losses, right? In other words, they are willing to accept some risk to avoid or avert a certain loss, right? Also notice that the utility function for losses is much steeper than the utility function over gains, right? This implies that investors are much more sensitive to losses than to gains. Now, central to prospect theory is also this idea that people would much rather take risk to avoid losses, right? You saw that in the loss region, people are in fact risk-seeking. This is what some people might call get-evenitis, right? This explains the behavior of investors with losing positions who show a strong desire to just get back to break even. In other words, they will take risks and they exhibit risk-seeking behavior when facing a loss. And of course, some people learn about get-evenitis the hard way. I don't know if you recall the case of Nicholas Leeson, right? Leeson, of course, became very famous in 1995 for having caused the collapse of Barings, right? A British bank that was more than 200 years old. How? Well, he essentially lost $1.4 billion through trading. So what happened was in 1992, he started trading bit rogue, in a rogue way, right, to cover up errors made by his subordinates. But it didn't really go his way, and soon, right, he incurred additional losses, and he eventually, right, let get-evenitis get better of him, right? In his words, what he said was he gambled on the stock market to reverse his mistakes and save the bank. He was just trying to recoup, right? Get even, right? But of course, he lost it all. All right. So in this lecture, you learned about prospect theory or loss aversion utility, which is based on the idea that people hate to lose. So we treat gains very differently from losses, right? Prospect theory can explain, for example, why we buy insurance at the same time that we buy lottery tickets. Prospect theory can also help us understand some of the examples we looked at in earlier lectures, right? Why people make different choices in situations with seemingly identical outcomes, right? Prospect theory, in other words, can explain framing effects.